Simplifying rational expressions. A rational expression can be simplified just like a fraction. So let me show you an example with a fraction. Let's take negative 18 over 36. We can simplify that. How would we do it? Well, we could divide the top and bottom by a common factor. For example, each is divisible by 9. So divide by 9 on the top, divide by 9 on the bottom. That would be negative 2 over, and 36 divided by 9 is 4. Oh look, it's still simplifiable. So now I can divide the top by 2, divide the bottom by 2. So negative 18 over 36 can be simplified into negative 1 over 2. So that's what I mean by simplifying a rational expression. If the top and bottom have any factors in common, then we should be able to simplify it. So I'll show you an example of one where we're starting with an already factored numerator and denominator. So on the top, we have 5x times x plus 4, and on the bottom of this fraction, we have 15x times x minus 4. Well, is there anything in common on the top and bottom of each fraction? Well, the 5 and 15 have a 5 in common, so I could simplify those, divide each by 5, and I'm left with 1 in the numerator and 3 in the denominator. I can also divide the top and bottom by x. So if I divide the top by x and divide the bottom by x, they cancel. That would leave me with x plus 4 over 3 times x minus 4. So I've canceled the common factors on the top and on the bottom, simplifying my fraction. Now, one thing we always need to note in each problem is non-permissible values. And so we always start with the very beginning fraction before everything has been simplified. And we say, what is x allowed or not allowed to be? And we should say what it's not allowed to be. So here, 15x times x minus 4 is not allowed to be equal to 0. Well, that means that either 15, I'll put the 15 with the x just to see what that looks like. 15x is not allowed to be equal to 0, or x minus 4 is not allowed to be equal to 0. So if we divide each side on this first one by 15, well, 0 divided by 15 is just 0. So x is not allowed to be equal to 0. And also, x is not allowed to be equal to 4. So we're just stating the non-permissible values for the simplified rational function. What I'll show you in this next example is how we're going to tackle the same type of problem where we don't begin with factored polynomials. So again, we'll start this example by noting the non-permissible values. So in order to do that, we're going to have to factor the denominator. So x squared plus 8x plus 12 is not allowed to equal 0. So we have to factor this. So we need two numbers that multiply to 12, positive 12, and add to 8. Well, that would be plus 6 and plus 2. So we have x plus 6 times x plus 2 is not allowed to be equal to 0. In other words, x is not allowed to be equal to negative 6 or negative 2. So those are my non-permissible values. And once we've done that, we're going to go back to the fraction and simplify. Now I have to factor the numerator. So I'm looking for two numbers that multiply to positive 6, add to positive 5. That would be x plus 2 and x plus 3. And I've actually already factored my denominator there. I did that when I found the non-permissible values. So I can just go ahead and factor the denominator very quickly because I've already done that before. And now we take a look and see if there's any common factors on the top and bottom of my fraction. And sure enough, x plus 2 over x plus 2 cancels out because x plus 2 divided by x plus 2 is equal to 1. Basically, when we're simplifying polynomials, it's the same thing we were doing with fractions, which is to divide the top and the bottom by the same thing. If we divide the top and bottom by x plus 2 each, then they would cancel out on the top and bottom. So this is basically a review. This is what we do when we simplify fractions just with numbers, is we're dividing the top and bottom by the same thing to cancel out common factors. Well, the same principle is applying here to simplify rational expressions. So after we've canceled out common factors on the numerator and denominator, we're left with just x plus 3 on top and x plus 6 on the bottom. And there's no other common factors to be canceled out. So that's our simplified polynomial, and we've also identified our non-permissible values. So we're done. I'm going to run through this example a little bit quicker. Again, start with the non-permissible values. So in the denominator, 6a squared minus 24b squared is not allowed to be equal to 0. And so I'll start, we have to factor this by factoring off a 6 from each term, because that's a common factor. So divide 6 off each one, and we're left with 6 times a squared minus 4b squared. It's not allowed to be equal to 0. Well, that is a difference of squares, which means that we have 6 times a minus 2b times a plus 2b. It's not allowed to be equal to 0. And so it's kind of funny, but at the end of the day, we can still say what our non-permissible values are, which is, from this bracket or from this bracket, those brackets are not allowed to be equal to 0. So a minus 2b is not allowed to be equal to 0, or a plus 2b is not allowed to be equal to 0. Which means a is not allowed to be equal to 2b. And you notice that there's no real single solution to this because we have two variables in each equation. And that's fine. That's as far as we can get, is to say that a is not allowed to be equal to 2b, or a is not allowed to be equal to negative 2b. So that's fine. We can't say any more firmly what a is not allowed to be equal to, but that's good enough to say we've identified non-permissible values. Which means that, for example, if b was equal to 1, a would not allowed to be equal to 2. So the non-permissible values sort of depend on two variables. So now we can go ahead and go to simplifying. So we're going to take our fraction and we are going to simplify the numerator and the denominator and factor what we can. Well, in the numerator, we can factor away a 3 from all three terms. So factoring off a 3 leaves us with a squared minus 4ab plus 4b squared. And in the denominator, we've actually already factored this all together, which was 6 times a minus 2b times a plus 2b. And now we'll go ahead and simplify this fraction a little further, which is going to require us to factor the numerator term. So can we factor that numerator? So we need to find two numbers that multiply to plus 4 and add to negative 4. That would be negative 2 and negative 2, which means, sure, we can factor this. This would be a minus 2b and a minus 2b in the numerator. And then everything on the bottom is just what we had before. And we're at the point where we can look for some common factors. Well, 3 and 6, just to start with the numbers, 3 and 6 have something in common. They can each be divided by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. And then what about our fractions? Well, about our polynomials, the factors, a minus 2b is present on both top and bottom, so they will cancel out. So we are left with a minus 2b up in the numerator and 2 times a plus 2b down in the denominator. So that's our simplified expression. In this last example, I'm going to skip the non-permissible value step just for time's sake, because you've seen a few examples of that now. And what I want to do is I just want to show you what would happen when we try to simplify this rational expression. So we're going to start by factoring the numerator and factoring the denominator. So in the numerator, we're two numbers that multiply to negative 32, add to negative 4. Well, that would be x minus 8 times x plus 4. Negative 8 times 4, negative 32, and they both add to negative 4. In the denominator, we have a difference of squares, which is 8 minus x times 8 plus x. So I factored my numerator, I factored my denominator, and now I look at them and I go, there's nothing in common, so there's nothing that can be simplified, right? Except that these two factors right here are very similar. In fact, they're only different by a factor of negative 1. And we've seen examples of this before. So I'm going to actually rewrite the numerator here. And what I'm going to do in the denominator is I'm going to factor out a factor of negative 1 from this first factor. So factor out a negative 1, that leaves me with negative 8 plus x. So I've divided off negative 1 from each of those terms. And the second bracket I'm just leaving alone. Well, now what we see is actually we do have some cancellation going on, because we actually do have a factor of x minus 8 on both the top and the bottom. So I can go ahead and cancel those two terms. That leaves me with x plus 4 over minus 1 times 8 plus x. That's not the nicest way, just, for your own interest, how you would usually write this as cleanly as possible to make your math teachers happy is put the negative outside of the fraction and drop any unnecessary brackets. And I'm also going to write the denominator as x plus 8 instead of 8 plus x, because usually we like to lead with the variables. So that's how you simplify that as nicely as possible. And note that I've skipped the non-permissible value step, so it would have been good to identify the non-permissible values here. But for time's sake, I just wanted to show you the main point, which came in this step down here, which was about that you have to be aware of opposites in factors and how those can affect your answer.